The next part of our video involves finding the intersection of a line and a quadratic. 3 different cases are possible. You can have 0 points of intersection, 1 point of intersection, or 2 points of intersection. We're going to look at a couple of different examples. You'll notice in question 3, we're asked to find the intersection of y equals x squared minus 2x plus 5, a parabola, and the line y equals negative 2x plus 6. In both of these equations, y is isolated. This sets this up perfectly for substitution. You can also use elimination, just like you did with systems of 2 lines in grade 10. Let's start by numbering our equations. The first equation and the second equation. We're going to substitute equation 2 into equation 1. So we end up with negative 2x plus 6 equals x squared minus 2x plus 5. And what this does is that it allows me to now have one equation with one unknown, and I'm able to solve it. Let's bring everything to the right-hand side. I'm going to add 2x to both sides. And I'm going to subtract 6 from both sides. When I simplify, I end up with x squared minus 1. This is a difference of squares that I can now factor. So x squared minus 1 factors to x minus 1 times x plus 1. And I have 2 different x values where this line intersects the curve. I end up with x could be negative 1 or x could equal positive 1. I now need to substitute both of those values back into equation 2. You could substitute it into equation 1, it's just that the calculation's easier with the line. Y equals negative 2 times negative 1 plus 6 gives us 8, or y equals negative 2 times 1 plus 6, which gives us 4. Therefore, the solution to this system is negative 1, 8, and 1, 4. These are the 2 points where the line intersects the curve. Our last example asks us to solve the following system. It gives us an equation of a line and a curve again. In fact, the same curve. The only difference is that our line now is in standard form, so we need to maybe do a little bit of rearranging first. Solving the system means the same as question 3 above, which is just to find the point of intersection. Let's again start by numbering our equations. This time, I'm going to rearrange equation 1 to solve for y. I don't necessarily need to do this step because y is already isolated in equation 2. It just makes the algebra a little bit easier. So I'm going to subtract 2x from both sides and add 5 to both sides so that my equation for my line is in y equals mx plus b form. Now I can substitute equation 1 into equation 2, and I end up with negative 2x plus 5 equals x squared minus 2x plus 5. In order to solve this, we have to make sure that it's set equal to 0. So I'm going to be adding 2x to both sides and subtracting 5 from both sides to make sure that I end up with 0 on the left-hand side. So I end up with 0 equals x squared minus 2x plus 2x plus 5 minus 5. Everything cancels on that right-hand side, and I end up with x squared equals 0. If x squared equals 0, that means x equals 0 because 0 times 0 is 0. I end up with one x coordinate for a point of intersection. So I'm going to end up with one point of intersection. I'm going to now substitute that into equation 1. So y is going to be negative 2 times 0 plus 5. Y equals 5. So my single point of intersection here then is y is 0, 5. So 0, 5 is the point of intersection. It's the solution to the system of equations. So I just used substitution. I could have also used elimination, just exactly like we did in grade 10.